Good afternoon, all.
Good afternoon. Good afternoon.
Good afternoon, Praveen.
Am I audible?
You are.
Yes,
Yeah.
ma'am.
Yes,
Yes.
yes.
Yes, yes.
JayaVamsi?
Am I audible?
Yes,
You're audible,
yes.
but not.
Okay.
Could you please switch on your video?
Yeah, sure.
Thank you. Yeah, thank you. So, my quick question, what's the session name?
Demystifying cryptography or cryptography. Not one. Sorry.
Anyone?
I can do a trickography, but not cryptography. I can do some
What you
tricks.
can do? Cryptography.
Trickography, some kind of
Tric-
tricks.
tric- Sorry, I'm not able to pronounce it.
Some kind
Cryptography. Okay.
tricks. I play tricks.
Okay. Okay. So, welcome, JayaVamsi. So, JayaVamsi, you can start the session.
Yeah, sure. First of all, thank you so much for having me, and good afternoon, everyone. My name is JayaVamsi. So today we'll be exploring this leastly explored field, that is cryptography. So this is a 101 session. So basically, I'll try to keep it simple, most probably, because there are a number of things to explore in this field. So initially, I thought to keep it like a foundational one, or you can say just like the basics things which we need to explore in this domain. So you may think, okay, if a guy is there in security field, so I mean probably he might use in this corner. So it's not like that. It has to be known to everyone, especially in development field. So we're all working in a development field, right? In one way or the other, like some way from the QA or some way from the development team. So overall, in single perspective, so we are from we are making things and we are testing them. So we have to know like some fundamental things regarding this cryptography. So probably we have came across this subject in our graduation time, those terms like for that instance we do remember, and then later we just forget, right? So it's natural, quite natural. Now we won't dive much deeper into the algorithms or the science or computational analysis which are behind those algorithms. We'll just keep the basic things or the basic resources which we need to explore during our day-to-day development life. So yeah, let me just quickly share my screen. Yeah, I hope it's visible.
Yes, Vamsi.
Yeah, and one more thing, like I just want to make it interactive because we're all in a same room, so here is no stranger over here. So just feel free to say anything you would like to. So you're free to unmute yourself, go ahead with your doubts or anything like that. So yeah, okay. Now, okay, just tell me like what things come to your mind when you hear the word cryptography. Anything?
WhatsApp.
Bitcoin,
Okay,
encryption,
cool, cool. More great
encryption,
answers. Okay,
Web3,
crypto coins,
super. Yes, please go ahead.
blockchain,
Cool. So I see most of the people are much interested in the cryptocurrency. So you guys are having some NFTs or what? Like most of the people are replying, what do you call Bitcoins or all these things. So it's, I think this is the future, the Web3 or, so I think the Brave browser, which we often use, is a kind of Web3 application itself. Yeah. Cool. So let's keep this thing like be interactive like this way so that it would be easy for us to learn in a collaborative manner. Yeah. All right. So the first and foremost thing is the CIA triad, basically. Okay. I remember you guys have heard about it during your college days or something like that. CIA triad. It's like the
Yeah.
so in order to learn any language, you do learn about the alphabets, something like that, right? So it's kind of stuff like in networking field or any security related stuff. This is the first and foremost thing which we need to be aware of, the CIA triad. Okay. Instead of describing what is what, let's keep it in an applicative manner. Okay. I'll first try to mention what is what, like the what does this confidentiality means, or the integrity or the valuability means, and later we'll just try to explore in our day-to-day life the actions which we perform. So we'll try to segregate them according to these terms. Okay. So basically the first, I mean, okay, so yeah, cryptography basically first we'll start with that. As you have mentioned, it's about the cryptocurrency, everything like that. Okay. The first thing is like cryptography is a way or the art to um, make the information or the data in an unreadable format. All right. So don't get confused between the encoding, encryption, all these terms and all. I'll just make it simple for you later. So yeah, behind cryptography, there's a lot of math involved. So that's why people often don't pay much attention to the algorithms which are involved. Okay, there are a lot of math involved behind cryptography or any algorithm which is present in the cryptography. Okay, so just understand that it is a way or the art of making the plain text or any data in an unreadable format so that only as a you know what is that and your receiver knows it. Okay, so for in this mid transition there are a number of things happen. Okay, we'll look at them later. So for the time being, it is the art of converting the data in an unreadable format. All right. Now, as we are talking about the CIA triad, so the C obviously means the confidentiality. I is referred to as integrity, and then likewise A is referred to as the availability. Now, let's say you people, I mean, we do build some API stuff, right? Or the endpoints and all. Okay. So, what do you think if there's an admin endpoint and if there's a normal let's say if there's a HR endpoint and then a normal employee endpoint, how would you segregate the authorizations? Feel free to reply to this question.
Like
How
we
will you
will give
ensure?
access, like
Yeah,
we'll give you access to only their related databases. Right. We will not
cool.
give, like if there is a client, he wants to access the data, we will give the data of that client. We will not give it, give him the availability to the HR or other data.
Okay, so how you're ensuring, I mean, the privileges between the employee and the HR endpoints or the data?
Uh, by giving them a specific ID, like identification like code or anything. But
Okay,
I'm
that
not too sure about that. That's
yeah, that's fine. That's completely fine. So basically, here talking in development perspective, we do have some roles and claims involved in this process where we do specify the authorization levels for every user present in the database. So like, let's say there are some confidential endpoints such as the payroll or anything stuff like that, or the leave management stuff. So they are to be accessed by certain roles or the claims which are set initially, like the HR admin or something like that. So those are to be not accessed by the normal low privileged users or the low right users. I mean, the employees and all. So all these things comes under the. Can anyone make a guess in this from this triad?
Confidentiality.
Absolutely, as it is mentioned over here. Yes, absolutely, confidentiality. Now, let's say, let's take this example, appraisals. Okay, this often happen naturally. So we are not supposed to discuss anything related to that. Okay, so that means it would be between your manager and the employee. So what is this? Will this come under? I mean, you just throw your perspective on this. Will it come under confidentiality, valuability, or integrity?
It is availability.
No, more answers. It's okay to answer anything with that.
Yeah, is this confidentiality?
Cool. Yes. So don't get stick to the sentences which are referred to over there. So just try to inculcate the actual definitions or the concepts behind those words, such as the confidentiality, integrity, or the availability. Okay, as it is mentioned over there. So the authorized things will come under the confidentiality. All right, such as previously, which what we have talked about, and later the appraisal part and all. So that will come under confidentiality part. And let us say if I am communicating to you over some platform such as WhatsApp or anything, and I'll be sending one message to you, and you need to receive that message. Is there any guarantee that you will be receiving that exact message which I'm sending, or are there any possibilities to break that thing? So
I
let's
mean,
say
it can be broken by WhatsApp, right?
no, not only WhatsApp, I'll just referring to one platform. So we are using one protocol or some platform between me and you, and I'm trying to send some data such as some music or text or what kind of data it would be. I'm trying to transfer the messages from my source to the destination or the client to, I mean, from one person to the other person. So it has to be the same, right? So whatever the files I'll be sending you, you have to be receiving that only. Instead, if I send hi, you shouldn't be receiving bye, right? So this manipulation or the what do you call that originality would be dealt by this integrity part. Okay, have
Yes,
any
got it.
okay. And availability. This availability means uh, whenever you refer or what time, like let's say you have a database created for your employee management system, and you have already created tables for HR or the employees, or you do have some foreign key constants, or everything it was set up already. Okay, especially the data. So the next day if you go, it has to be there. It shouldn't be like unless and until you perform some other actions on that database or any other thing, it shouldn't vanish, right? So whenever you are referring to some data at some source, it has to be available. So that is nothing but the availability. Okay, it has to be accessible. Let's say if a document is there that has to be particularly accessed by this HR team, and obviously it will not be accessible to the employee because it was maintaining that I mean it was maintaining that what do you call authorization levels, I mean the confidentiality. Now it shouldn't be like okay whenever the HR team refers to that document, it should be there. Instead, I mean it should not vanish. So this will something comes under this availability part. All right, I know these are pretty confusing right now, but if you try to segregate the tasks, like whatever the day-to-day actions you perform. If you try to think in these three terms, obviously you will get habituated. Okay, this will come under this confidentiality, this will come under this integrity. You'll map like that. All right. Are there any questions over here up to this?
No, Vamshi.
Okay. I can sense that this is boring, but I'll assure that going forward it won't, because there are a lot much puzzles are waiting for you guys ahead. Now let's see the another thing, which is encoding and decoding. But before that, I would like to explain some key concepts in the basic key concepts in the cryptography. Okay. Um, okay, let's do one thing. I hope the notepad is visible, isn't it?
Yes. Yes.
Yeah, cool.
Yes, it is.
Sure. So let's say um, what's this? This is a normal plain text, right? Or the basic strings. So
Yes.
basically, yeah, this is a plain text. A second. And this, can anyone guess what was that which I shared in the second line?
It's an encoded word.
Absolutely. So can you define encoding in your terms?
So basically, if even if the only person ideally should be who will be able to decode it would be that particular object which has been using. For example, WhatsApp. Every message we type is actually encoded and been transferred to another form, and that form will only get converted to the raw form which has been sent, will be done only in the particular user's account. No other place, no other account it will get converted. So that's why that information is known and the exact information is passed. That's why if you notice in WhatsApp, it will be message end-to-end encrypted. So that this is encoding and decoding which is happening over there.
Appreciate for your time in answering. I do agree, but the thing is, whatever you have said is absolutely correct. But then we that is something related to the encryption part, because encoding and decoding, like, it is the way to represent the data. So this plain text, I am Batman, is being represented. So I'm trying to represent that plain text in a form of data. I mean, in one form. So when we are trying to represent a plain text in a form, so that is something referred to as a and I mean, that is something referred to as encoding. Likewise, so the reverse of converting that transform text into the readable format or the original state is referred to as the decoding. Please don't get confused between the encoding and encryption. Both are completely different. Okay, so we have taken this string and then, or the plain text, and we are trying to represent that in another form. Okay, as you can see, these both, I mean, both of these statements are completely different, right, in visual, but they do represent the same form, that is the same thing. Let me just show you. You can clearly say that this is encoded form, but can you identify, like, what kind of encoding mechanism we have used?
Any ciphertext?
Sorry. Yes, absolutely. I mean, whatever the thing which is not readable or in the original state is referred to as ciphertext. That was the next thing which I was about to tell. So yeah, this is the plain text, and these two things are referred to as ciphertext. All right. Now, as I mentioned earlier, both of these two strings do represent the same string, that is, or the same plain text, whatever we have given. But then I have used different mechanisms to encode these things. All right. So first we need to identify what kind of mechanism we have used over here. So for that purpose, we can use a number of online resources for that. But I do prefer to use this thing, which is referred to as tunnels up. So don't worry, I'll be providing all these resources at the end of the slide, and we'll be sharing with you. So let's just copy this thing. So whenever you're unsure about what kind of hash or the ciphertext it is, you can just hop onto this site and then click on analyze. All right. So it has analyzed that this character string is of type base64, which we can conclude that we can decrypt this, or I mean, my bad, we can decode this using something called as base64 decode. Okay. So for that, let's just see how it goes. So this was a string, right? So we'll try to decode that. See what it has written. The plain text which we try to convert it in or represent it in a different manner, right? So here in this example, we were using an encoding mechanism, something referred to as base64. We do uh, come across this kind of encoding mechanism in our day-to-day development life. Okay, but what is this then? This is also another form of representing that plain text in another form. Like, so this is something referred to as rod 47. Okay, so what happens is, like, every string, let's say a alphabets will be there, no, like A to Z. So A would be rotated to some up to the 40 up after doing the 47 rotation. So A's first rotation would be B, A's second rotation would be C. So like that, there are a number of encoding mechanisms which we can use to represent this data. So all these things will come under encoding. All right. So that is what we have presented over here. So encoding is a process of converting information on the plain text. Not only plain text, we can even convert or encode things like images or anything like that, and then into a format that can be transmitted securely. All right. But then, I mean, this encoded information would be again transformed into some algorithm. So here we'll be placing different kinds of algorithms, cryptographic algorithms. Some are SHA-256 and RSA, AES. A lot number of things are there for implementing these things. And again, this is completely optional as of now. For understanding encoding and decoding, we are given one plain text, so we are representing that in another unreadable format. So that was something we have seen, that is base64, and there are mechanisms like that, such as Caesar cipher and all, which do the same. Please listen to these things carefully, because at the end I'll be giving one challenge to solve. So these things would be helpful to solve that challenge, and whoever solves that, L&D team would be providing you some gift and all. Yeah. So what you have covered so far, the plain text, ciphertext, all right, and the algorithms. Obviously, we have not seen anything much more into these algorithms, because there are a number of complex things over here. Since it is a 101 session, we'll be dealing with all the basic fundamental things. All right. Now, for algorithms, we do require one thing called as the key. Okay, so that key is nothing but the secret which is used to encrypt and decrypt. We'll be looking at next. All right, now let us move ahead. So after diving to this thing that is encryption and decryption, we can actually, you know, identify that encoding is lot way different from the encryption. All right, now let's say, as you have mentioned that WhatsApp thing, so everything was written like messages are end-to-end encrypted. What does that mean?
Actually, we send a message that is encrypted, and that encrypted message will be sent to other person. That that encrypted message will be decrypted and shown as a message to that person.
All right, but why do we need to encrypt? Is there a necessity? Why we are doing that?
That WhatsApp is a security that we need our message to be secure. That's why anyone don't want to access that. So we use encryption and decryption in WhatsApp.
So not only on WhatsApp, any communication channels would be using the encryption and decryption mechanisms, and even we are using, especially while developing things for the client or anyone. So we have to use encryption mechanisms in order to protect our data. So that is the first and foremost thing. So, but then why, if it is not encrypted, what happens?
Anyone
We
on
will be
the
lost. Yeah.
Sorry.
So about the confidentiality and integrity purpose, we'll most use encryption techniques.
Cool. Yeah, so likewise, you'll bring all those CIA concepts over here practically so that you'll remember those terms. So why we are using those things and all. All right. So have you ever thought, okay, just tell me your opinion, your all opinion. So what are, I mean, what's the difference between HTTP and HTTPS?
security layer is added in HTTPS.
So, I mean,
The data
like,
gets encrypted or encoded when it goes through SI. In HTTP, the data goes like other raw data is being sent. And I think that's the reason why WhatsApp uses encryption, because anyone in the network can see the data if it's being sent as raw text.
absolutely. So this is the point I was waiting for. So the thing is like, why do we encrypt is like, I mean, if it is not encrypted, it would be transferred as a plain text. So what do you think? So whenever you're sending a message to the other person, what do you think how the message would be transferring from your thing to the other destination? Will it be going in a plain text?
Nope, it
No,
will
It
be
won't.
ciphertext.
Will it be encoded or encrypted or both?
both.
Absolutely.
Both.
So let's say I have encoded and I have not implemented any encryption mechanisms for my thing which I'm building. So is it called secure even though I'm on HTTPS?
It won't be secure at all.
Absolutely. I mean, appreciate you guys like you're on the right track. So let's see what encryption and decryption does. Like how different are these from encoding and decoding? So encryption is the, let's see this image. So this is the plain text, right? I'll be having some data. Here we are performing encryption. We'll look into that. Here we are having a key, and that would be converted into unreadable format, which is often referred to as ciphertext. And then we'll be sending it to our destination, where our destination needs to decrypt that received data with the key, and then he or she will be able to read that in the plain text format. Now, if this is the entire process for encryption or decryption, but then if if a particular entity is using the same key for encryption and decryption, that would be referred to as symmetric cryptography. All right, and if any entity is using different, different key and one key to encrypt and the other key to decrypt, they'll obviously different. So that would be considered as a asymmetric cryptography. In this session, we'll not be dealing much more into that because that would be complex, but we need to learn the basic things over here. So that's what I'm expecting from the after this session, right? So yeah. So what's the key role over here? The role of the key ensures that, yeah, please, someone was saying.
Yeah, it's about the algorithm which we are using to encrypt the data and decrypt the data.
So absolutely. So the thing is like the key we can set that, okay. From application to application, this gets changed actually. Let's say there, let's take one example. Let's say how many guys of aware of SSH protocol, secure shells? All right. Okay. Yeah. Please. Yeah. Please feel free to answer that. Someone raised their hands. Secure
SSH is
shells.
basically provides a secure layer between uh, the provider and receiver.
I believe you were talking about SSL. I was mentioning about SSH. No problem. So let's see what happens. So SSH refers to the secure shell where we do connect to the remote host from our terminal. So let's see in a practical manner. So let's say so this is the tool called as Wireshark, where we do sniff the network and look for the traffic. Let's say I'm in a public cafeteria. I have gone to one public place and I have connected to Wi-Fi, public Wi-Fi, and I was I was performing this sniffing thing. Like I was monitoring all the incoming and outgoing traffic from in the connected network. So in this case, as we mentioned, as we talked about the cryptographic concepts, that is HTTP or HTTPS, if someone is performing some transaction, let's assume that, all right, someone has connected to the same network or residing in the same network is performing some transaction, but unfortunately the transaction which he or she was performing was on HTTP portal. So in that case, I can actually use this tool to get all that their card CVV details using this tool. That means that you're understanding, right, the impact of cryptography or the role which is playing over here. So if it is using HTTPS, all right, if it is using HTTPS, that entire card information or the information which we're sending from our end to the server gets encrypted, and even though we intercept or sniff that network or the packets, it will be in a cipher format or unreadable format. So that's how much it is important, the cryptography thing. And then um, but this I would like to add one more thing, like this doesn't ensure that just because that particular site is having HTTPS, that doesn't ensure that you're completely secure. You need to validate the authenticity of that domain. Even I can set up a HTTPS website and spin up some fake products and then um, take orders from innocent people, and then later I can manage. So you need to make sure that that particular domain has the proper authenticity. Especially we'll come across all these kinds of websites across Instagrams and all. So there would be a number of remote remote selling items with a number of like domains. The thing is like you need to validate the authenticity and then you need to perform the payments and all right. So here we were talking about the SSH, right? So let's hop on to this thing. Just a second. Think it's blocked. Whom do you think it was blocked by? Can anyone say? Who blocked that site?
The network team of sales.
Absolutely. So let's bypass that thing. So now what we'll do is like we'll try to connect via VPN so that we would be able to access that website. So the thing I was trying to explain you or demo is that uh, SSH. So this is very important because especially sometimes you need to connect to the remote host of your clients or something like that. Not only clients, just see this as a concept like there's a remote host which is running over here, or let's say you are at some place and you need to connect to me. So I'll be but there has to be some communication, right? It's not like I'll give you the username and password and you get connected to me. So some kind of mechanisms would be happening at the back end. So a lot of cryptography stuff is there behind the communication aspect. So SSH is a secure shell uh, where where you'll get a chance to connect to the specified host with a username and password, especially the this basically runs on the RSA mechanism. So don't just confuse like it requires two keys. I mean it has two keys, public key and the private key. Okay, you will be the private key. Yeah, you will be able to connect to the remote host with these keys. So as I mentioned, like we were talking about the keys, right? Here, we'll be having the for encryption and decryption, we'll be having the same keys. So this comes under symmetric cryptography. And if you require two different keys, so for one for encryption and the other for the decryption, so that would be coming under asymmetric algorithms, asymmetric cryptography. All right. So these are the things like let's say in application perspective, so as we mentioned, this uses a shared key for both encryption and then the decryption. So, but efficient wise, symmetric cryptography is much more efficient than the asymmetric cryptography. All right. So mostly for file transfers and all, mostly people do prefer symmetric cryptography. All right. Let me just give some more examples for these things. Let's say you're sending an email. All right. So for that purpose, what do you think? Will it come under symmetric or asymmetric?
Symmetric.
Why?
Uh, I'm not really sure, but I think it is more efficient to use a single shared key for emails.
Okay. So the thing is like we have talked about the what do you call integrity, right? Or else the the intended receipt has to decrypt the message. For sending mails, will use asymmetric cryptography, you know, because it ensures that only that intended receipt can decrypt that particular sent received message. And let's say you're building some application and you're storing passwords. So what what do you call that? I mean, what concepts will you use over there? Will you store directly or there's
Hash.
one term? Absolutely, absolutely. So which hashes do you prefer to use or we have came across mostly?
SHA.
Okay. And then the vintage MD5 that was deprecated because it's not that secure. So instead of that, we are moving ahead with more secured algorithms such as SHA. There are in that SHA also there are a number of types such as SHA1, SHA2, SHA256 like that. So yeah, it's preferable to use SHA over MD5. That's what we can say. But never ever try to store the passwords in the plain text. Okay. Let's say even though you're encrypting or you're hashing the passwords and then you're storing, all right, but then there are a number of mechanisms to break them. All right. Let's say there's a mechanism called as rainbow table where it will have the list of all the hashes or pre-computed hashes and it will try to map that computed hash with the hash which is being stored over here. So it becomes easy to crack that as well. So in order to bypass these things, I have some points to add. So please try to solve the passwords. I mean, solve the hashes, not passwords, hashes. So whenever you're taking, you're trying to hash the password from the user, you please try to solve them. So solving is something like will add some string, set of string or characters or anything to the hashed password. I mean hashed password, and then we hash that. So even though someone breaks that, it won't be the same. You're getting the point, right? So let's say my password is Batman. So when I hash that, I got this string. So let's assume like this. So this is the hash I got after hashing the Batman. Now, the same hash could be found somewhere in some database, or it's easy to, let's say I have some word list containing these elements such as some you are aware of word list, right? So word list is nothing but the text file which consists of all the words such as anything we can generate with our requirement. So basically it has line by line entries and what it will try to do is that when we try to brute force these kinds of hashes, it will try to look up for those word lists and then it will try to map that hash with the entry present in that word list and it will give us the password like that. So in order to bypass that, please add salts. Let's say this is the hash for the computed plain text, right? So I'll be having, let's say I'll be setting some salt as some random string in my env file or somewhere like that. Okay, this would be something like some random string. So I'll be using this random string for hashing for salting this hash. So this will generate some random stuff, not the same, but some random thing would be generated, some random hash would be generated. You are seeing the difference, right? When we hash this plain text, we received this hash. When we added this salt, when we added salting for this hash, we received another hash. So even though someone tries to break this out, they won't get the original like, original plain text. So that's the point I was trying to convey. I hope this is clear, or you have anything, please feel free to unmute yourself.
Can we hash that? Uh, can we double hash that? That means if Batman has something came as hashing, that that particular hashing, can we hash that again? Then it
Yes,
will be.
yes, absolutely. So that concept comes under roundings. So let's say for any algorithms, you can perform roundings. So even those can be also broken in one loop or the other via different kinds of tools such as Hashcat or John the Ripper. All these tools are there pretty good outside where we can do the stuff by specifying the flags such as rounds and all and do the stuff. But then I think salting is something makes some more secure. And there are some points to be added from users perspective or the public perspective as well. So please try to let's take some passwords randomly. So or anyone, can you please drop your email in the chat box, your old unused email or anything like that. I just want to showcase something. Thanks for sharing. So I'll walk you through one site which is very important for everyone to know about this. So that is Have I Been Pawned? So if I just give your here you can provide your own email address, nothing wrong, but this makes sure that you will get aware whether you are in breach. Oh my god, you was pawned actually. So this site or this portal, what it will try to do is like it will try to look up for your email addresses provided by you with the recent breaches or the past breaches which had occurred. So I did the same, like I have provided your email address and then you have found in one the data breach which was occurred in the 2022. So if you're using if you're using the password for this Gemini for any other portals, you please try to change that thing. Okay. If you don't do that, attackers might perform what do you call that password spraying attacks, such as reusing that password for different kinds of portals with the same email address, whether it be Facebook or anything else. Obviously, you'll be maintaining different passwords for different portals, but then lazy guys like me would prefer to use same password for every uh, portal. So in that case, please try to change your passwords from time to time. And then I would like to showcase another site. Can anyone drop your last changed password which you're not using? Something like that. Cool. Banana. Cool. So Shivam, who was that? Sorry, just a moment. Shiva Shankar. All right. So what do you think? How secure is your password? Like, is it totally secure? Like, what do
No,
you
no,
think
no.
about this?
It's like easily anyone can like, decode it.
Cool. So let's see how much time will it take to let's say someone is performing some brute force attack or some other kind of password attacks on your email or something. So let's see how much time will it take to crack your password. Oh my god, it would take around 400 years. Sorry, 1 second. Yeah, Shivam. So this password is taking about 400 years. That's good. And let's take another thing, which was banana fry 123. Okay. So it is taking about 3 years. So you can, the thing what I was trying to explain is like, so whenever you try to keep new password, you just try to hop onto this amazing site and just a second, how secure is my password, and then you can probably input that in this field, and you can estimate how much time will it take to crack it. So what do you think this is?
Password.
Yeah. And this, let me show you. So I have inputted sales and it is taking about 200 microseconds, which is, you know, okay. So let's do one thing. I'll tell you some things to make your password, simple things to make your password more secure. Like try to, you have came across reels, you might have came across reels. So you try to include commas into your password. So whenever you have found in some breach and all, if someone tries to dump your password, obviously they would do in the CSV formats. You're pretty good aware of CSV formats, right? Comma separated values,
Yes, sir.
email, comma, password. So let's say they have your email and password. So when it is having some comma in here, probably they would it would break their CSV file. So try to use these things and then let's convert this in a secured manner. Let's hope for that. So try to mimic these things. Okay. Okay. We have taken from some milliseconds to some hours. Okay. So this is taking about 3 weeks. The sales at the rate 1, 2, 3. So what if we just add comma? One single comma. It took from me from 3 weeks to somewhere 52 years. Same way, spaces. So commas and spaces are very crucial in setting your password. So please try to use them in your set password so that there would be it would become hard for the someone who tries to crack them. Okay, especially the spaces. All right. So as you can see, the same password sales are there at 1 to 3 got from 3 weeks to 52 years by inserting one small space or one small comma. Okay. Now let's see the next thing. So as we mentioned previously, hashing algorithms, so they actually transform the data into a fixed length. All right. And they cannot be reversed actually. They have to be broken. So what do you think the how hashing performs, like how hashing works? As I mentioned about the brute force attacks and all, that means let's say I have this text file passwords.txt. In this file, I'll be having these entries such as pass password I am Batman PC window. So let's assume we have one passwords.txt file and we have these entries present inside this passwords.txt file, and we have one hash. Okay, let's assume that this is the hash of this I am Batman. No. Okay, let's remove these things. This one as well. So let's assume that this is the hash of this I'm Batman, and we have this passwords.txt file. As you can see, our password was present over here, but then so I'm trying to explain how brute force works over here. So let's say you're trying to perform brute force attack. So brute force, not brute force. Okay, let's say you're performing some dictionary attack. So this is something considered as a dictionary, and you're performing that attack. And how it will try to look up for that is like I'll be setting some hash to that. Okay, the type of hash for that tool, and then how it will crack is like so it has got this input text input hash, right? So it will try to take the entries present in this txt file and it will try to do the hashing for all these text present over here. Okay, so let's see it in action. One second. I'll- So okay, so let's say we are trying to encode, I mean hash this. Okay, so the I am Batman. I'll be redirecting to one file called as some my password.txt. Okay. Now I'll use some utilities. You can use some online portals as well. So total hash file. The file name is my password.txt, and then I'll mention it is as MD5. As you can see, it has generated one hash, right? MD5 hash. So let's for instance, let's assume this is our hash. This is the original hash for this I am Batman. So when you try to perform the dictionary attack, it will take all the entries present in this particular file, and then it will try to find the hashes of all this. This will come some random stuff. Likewise for these things as well, the password, hi, and each and everything would have some different hashes, right? But please remember, I'll add one point to this, like what I've mentioned, like everything will have different hashes. Please highlight, I mean, please remember this. I would like to add something at the end. So likewise, we have got hash for this particular string, which is this. Okay, the exact thing. So while performing how or any password attacks or dictionary attacks, so while people perform, they'll this is the background process which happens. So it will take the entries, it will try to convert them into hashes, and then it will match the hashes with the input hash. So if it matches, then it returns the plain text or the entry. So this is how it happens at the backend. So it is necessary to perform. So likewise, so that's the reason I was mentioning to add some salting to this. So if you just add salt and while saving them or storing into our database in your development life, then you will be storing another hash that would be different from this hash, right? So even though they have the hash, but that won't return the exact plain text of the original plain text. It would return something else. So that was the thing I was mentioning about. Okay. Now, so there are many myths, like if you just implement cryptography, everything would be secured. So it's not like that. And if you use some supercomputers or high computational computers, it is pretty easy to crack any kind of password. Trust me. So it is a basic entry to it is basic and I mean necessity to secure your data from your end, or it's the basic right to create a platform or medium to encrypt your personal information such as PII info, which is first name, last name, or passwords, everything else which is relevant to your thing. But yeah, but it's not unbreakable. We can break them at any cost. And then I would like to add one more thing. So, like I mentioned while explaining MD5, do you think every entry would produce the same hash or different hashes for any kind of entry? So why do you think we have moved from MD5 to another cryptographic algorithms?
Because
This
those can be decoded easily now, because they are for a long time, right? So people have more time to understand how it works, how we can decrypt it. So we need a change in that. That's why in any of these algorithms should be not used for a long time. Uh, it needs to be updated daily, not daily, but in a
Yeah,
specific time
cool,
periods.
cool. So yeah, I mean, to some extent, like, so let's say if you're using the same hash, that would be decrypted easily. That's correct. But what if I have implemented salting and then hash that and storing? That would be secure, right?
But it's
I
a time consuming process, right? Uh, Instead of that, you can use another algorithm. Like we are adding multiple layers upon it, so it will also take multiple layers to decrypt it. So the time taken might, increase. That's why. Like it's a guess from me. I'm also not too sure about this.
Vamsi?
He's
Yeah,
facing
sorry
some.
guys. Yeah, just face some network issue. Yeah, please continue as you were saying something. Yeah, so you were mentioning that it would take some time consumption for decrypting via salting and all, right?
Yes, yes, ma'am.
Okay, so to be honest, that won't give, I mean, that difference. But the thing is, like, the main reason why we have moved from MD5 to some other new algorithms or symmetric algorithms like SHA or AES and all, the main reason is we have hash collision in MD5. So that means two different inputs are providing the same result hash. So that was the main cause why we have deprecated that MD5 and we have moved to some other hashing algorithms. So let's for that demonstration, let me just give one small example. I'll just take two uh, text items and then show you that part. So let me just fire up. I hope it's usable.
Yes, ma'am.
Um, So let's verify whether whether both are same or different. Okay, so this means that we have provided two different inputs, right?
Yes.
So
Yes.
don't get confused about this. So this is nothing but a plain text or some input data. You can prefer anything the way you like. So the main thing is like we're providing two input data and we have verified that both are not same. So here we'll be performing some hashing on this and we'll see both will produce same hash. Let's confirm that. You can think like by saying the prefix and the suffix, it seems similar, but I have verified the same over here by assigning them to some variables and then equating them. If both are same, then it would obviously return true, right? So you can observe the minor changes over here. So here it is written A, here it is written E. So probably both are different inputs. The same things I'm trying to saving them in a text file and then trying to perform the hashing over here. Such util file .txt 5. Similarly, second. Okay, my bad. So I see some issue in generating the hash by using certutil. So the main thing is like, so when you try to generate hash for MD5 hash or the MD5 sum for these two inputs, will probably provide you the same output, like the same hash. So this makes us to move to some other popular or secured algorithms for cryptography mechanisms and all. Yeah, so that's the main reason why we have moved like that. And then so these are pretty good. We have seen the encoding things and the collisions, and then now let's see this thing, the decryption. So I'll be providing you one challenge. Now you'll be solving that now itself, like live. Okay, but before that, just see about the tools and platforms. All right. Okay, so that these things like, so let's say for Google we'll be using some for managing our secrets and all, we'll have some secret manager. And similarly there's a HashiCorp world where we do use for the securing, I mean storage purposes. So for secure storage purposes, we'll for the secret keys, right? API key or any secret keys we'll be using from our day-to-day life in the development thing. So we can manage all those things using this HashiCorp vault. Similarly, if you see, there's a BitLocker present in our system, every system. Okay, this is also one of the tool which is present in our Windows machine itself. So you can actually perform, you can actually encrypt your disk using this BitLocker. So yeah, and then for these TLS or SSL communications, which are nothing but let's say this is this connection. So this is certificate is valid or everything HTTPS. So basically, so this means that it's under the secure socket layer, okay, or the TLS connection. I mean, your whatever the information which you're passing to the server is pretty safe or encrypted. So this validates that part, this TLS SSL tool. And for securing the emails and the file encryptions, we use OpenPGP. And then there are a lot more tools such as SFTP, Secure File Transfer Protocol. Previously, we used to have FTP. Even we do use FTP, but SFTP is much faster than FTP, and then it is much secured than FTP. So yeah, likewise SSH, Secure Shell, for which is used for connecting to the remote host and all. So that's also pretty secure because it it utilizes RSA mechanism for public key and private key generation and authentication purposes, but then it actually relies on AES mechanisms for you know for the network transferring protocols and all. So I hope, I mean, I'm intentionally not dealing much deeper into those algorithms because there's a lot of math involved. So if I just uh, go ahead and tell all those things at once, means that would, I mean, that gets you bored. So yeah. So these are the resources which I have mentioned. So you can, for analyzing hashes, you can prefer to use this. For cracking hashes and all, you can use this platform called as CrackStation, and Caesar ciphers, everything you can prefer to use decode.fr. And this is the most favorite site where we commonly use, that is JWT.io, where will pass the JWT token and we can see after decrypting what are the claims or anything stuff. We can just review them in this JWT.io. And this is most powerful tool, CyberChef, which is completely web-based tool. And then this completely has you know from encoding to encryption, everything pretty good. Is a one-stop solution for any cryptographic thing. Yeah. So it's challenge time. Okay, I'll just try to explain this. So whatever the things which you're seeing over here, these are the hints. All right. So this is the output thing. I will provide you this input. I'll provide you this input in the chat box. You try to, by using the hints present over here, you need to decrypt it and or decode it, not decrypt it, because I have not used, I'm mentioning again, I have not used any kind of encryption or decryption mechanisms over here. I have only used the encoding mechanisms. I have pretty good straightly given you the hints as well. So please feel free to go ahead and try to solve this now itself. In maybe in 5 minutes, you'll be able to do that. I'll just provide you that. So whoever solves that, LND team LND would be giving you some cookies. Just a second. So I have given something, so you're not sure what it looks like. So I believe I have provided you some portals previously to analyze the stuff. Maybe you can use them. So while you do this, I would love to go through the mails provided in the comments section to look for to look in this site. Okay, no pawn found. Great. Cool. I think that's not the complete plain text. Uh, Still it is, in the not readable format. Okay, so Sandeep had cleared one thing. So did anyone know what's this? The output thing or the input which I have provided?
Morse code.
Absolutely, absolutely. So people prefer to use, or there were times, or I think there are still they're using, like, we can actually play this actually in the website. It will provide some sounds. So this was the one form of communication for transferring messages and all. So meanwhile you can please use these hints to solve the challenge, and I'll try to play this one for you. So whatever you're hearing right now, that's the Morse code actually, which I have inputted over here. Directly you cannot say some message, but we can decrypt, we can decode this, not decrypt, we can decode this to retrieve our plain text. Okay, so this is something used for translation purposes, so I have given in that order itself. So how many of you have finished the first part? Please raise your hands.
Only one, Swapnil. Chaitanya.
Isn't it interesting to solve this challenge? You guys are not doing. Okay, so what's the next step? So you have inputted this over some portal and you have received some string. So I hope that's
I'm assuming we
so.
should take it to a base 64 decoder.
Absolutely. So please go ahead.
Um, I did decode it with the base 64
Okay.
format, but I think
Okay.
I'm getting some corrected values. I'm not sure
Yeah,
why.
Okay.
the values do not
Please
seem like
drop them.
ASCII.
Yeah, please drop them over here, what you're receiving.
Okay.
Really, you're getting that? Let me just
Yeah.
verify from my end.
Yes, I tried in two different sites.
Just a second. Just a second. Or
Vamsi,
yeah,
could you please check your team's message?
yeah, sure. We'll be wrapping up it in a while. Yeah, my bad guys. I'll 1 minute please. I'll be providing you another one. Okay. Can you please check with the updated one? Please use that cyber chef if something goes wrong.
excuse me, Vamsi, where did you send the updated?
Oh, my bad. Just a second.
Okay, okay, see.
So it's okay. I think it's taking time. Try it at your available time. So we'll wrap the session as of now.
So is the one I sent anywhere closer?
Did you send now? Just a second.
The 2020 National Day holiday is coming.
No, no, that's
Sent
not the
by
client.
Abhishek Yale.
Okay, okay. Is the thing supposed to be in Chinese?
No, no.
Okay.
So the thing is, so yeah, I'll explain you the stuff. So this is basically a Morse code, right? So that Morse code would be when you decrypt it, you'll get one base 64 string, and then yeah, after base 64, you need to, I have mentioned seized it, right? So which means I have used something related to seize. That means Caesar cipher. That's a popular data representation one. So you need to decrypt that. I mean, sorry, my bad. So you need to decode that with the hint provided over here, which is Ishwar Sahil's birth anniversary. So that is 9 July. You need to use the integer over here, that is 9. For decryption, you need to use minus. I mean, for decode, you need to use -9. For encoding, you need to use +9. So I have done the plus with +9. You need to do with -9, and you will be getting one string and plain text after that. So that's the entire challenge, basically.
Nice.
Yeah. All right, guys. Thank you so much. You have any questions?
So, guys, if you have any questions, please send a message to Vamsi in the chat box. Okay, so he will addressing you all individually because we are running out of the time, right?
Yeah.
And I'm sorry for interrupting Vamsi, and thank you
Yeah.
so
No.
much for facilitating this session. Okay, and we appreciate your efforts too. Thank you, guys.
Thank you so
Thank you,
much.
Vamsi. Yeah.
Bye.
Thank you, Manju. Thank you, Priya.